Hello everybody, just a little video for you because I noticed that a lot of you were getting this question wrong, and actually the mark scheme in the test was wrong too, but um, the test appeared to say that a lot of you were getting the right answer, but the actual answer in the test was wrong. So I'm going to go through it with you to explain how this is actually working. So we've got two solutions here, X and Y. A solution means that we have a salt dissolved. Okay, so there are particles of salt dissolved in this water here. So let's go, salt particles are black. This is a dilute solution, so we don't have that many particles of sucrose. Sorry, it's not salt, it's sucrose. In this case, it could be salt though. This here is a concentrated solution of sucrose Y, so we have a lot more particles of sucrose. So if you were to taste this one, Y, would be sweet, and this one not be so sweet. Right, now let's look at the water. Let's do water as it is in blue. Maybe I should have done the dots bigger, but we'll do the dots here, blue. Okay, so now I've got not so much sucrose in this one, right? So actually, I can have quite a few particles of water. Yes, there are the ratio of water particles to sucrose particles, keep on saying salt, sucrose, is a high number of water particles per sucrose. So we say actually here it's dilute, yes, but we also say the water or concentrated water particles. Okay, so we've got concentration. And we can also say, quite a lot of terminology here, that actually we now have high water potential over this side. So the potential for that water to move is much higher than the other side of this membrane because there's a higher concentration of water particles. So this side, we've got a much higher solution, concentration of sucrose, so there are the ratio of water particles to sucrose is much lower. Okay, so we say that this has a lower water potential. There is a lower potential of the water particles to move across this membrane in the middle. Okay, so concentrated water particles to high concentration of water particles to a low concentration of water particles. All right, so if we're talking then about this concentration gradient with diffusion, yes, the movement goes down the concentration gradient from high to low. Well, this is a form of movement, a form of diffusion, but it's actually we're talking about the diffusion of water here, which is what osmosis is. But we have a diffusion also down the concentration gradient of water particles. So wherever we have a high conc of water to a low concentration of water, that's the way the water is going to move through this membrane. This membrane's, remember, only permeable to water, not the sucrose. So we get a flow of water down here, this way. And remember, it's a net flow of water. There is some water moving this way, but there's much more water moving the other way than there is from Y to X. Okay, so we're moving down that concentration gradient from high to low. Imagine that's a hill with concentration being the height. Yeah. Okay, so the answer, for this one, in which direction will most water molecules move in relation to their concentration gradient? Well, we now know the concentration is high on this side, it's low on this side. Most of the water is going to move left to right, X to Y, down the concentration gradient. Okay, tricky question, but there we go, solved.